Hello Internet! In this video we are going to be exploring a brainworm that I've had over the past few days. We are going to be trying to explore what happens when you round the vertices of a mesh to a grid. And so we're going to do this with a shader, but I don't think this is going to turn out well for any of us involved. I don't see why you would ever want to do this. I just thought it would be cool. So we're going to see what happens. I have removed lighting from these, so these are unlit shaders that I'm exploring. We might, depending on how this turns out, we might try it with a surface shader or something just to see what like the standard lighting does here. I don't see that turning out well in any way. So we're just going to do an unlit shader and go from there. Basically, the idea here is we are going to manipulate the vertex shader. There are two real key parts of a shader. There's the vertex shader that comes first and figures out where things are positioned in space. And then there's the fragment shader, which takes all of those pixels of that object in space and colors them in for you. Effectively, the first part is building a paint by numbers thing. And then the second thing comes in and says, oh, this number is this. We're gonna color it whatever color. So we're gonna work with that first bit and figure out where all this stuff goes. We're effectively just going to round things to make them less of what they should be. So this is just a basic unlit shader. If you're curious how to create them, you just right click, create shader, unlit shader, and you can go from there. I'm pretty much in the same spot. I just named it something. So you'll get something that looks like this. You don't need to care about most of this. This is just all boilerplate stuff to get all of the stuff working. What we do care about is this vertex because that's what we're going to be manipulating. And this configuration here. So pragma vertex vert means that there is a vertex shader in this code named vert. And so if we scroll down here, we'll see a function called vert. That's what's actually going to be doing our vertex shader. And basically what this does is it takes in all that input from a mesh and translates it into camera space for us. And does a few other calculations by vertices. So models will have vertices that kind of represent what the model is. In this case, this is what's translating those to make sense out of them. At the very top here, we have properties. This is typically much longer if you do a standard shader. Let's actually just do that, because then we can just copy and paste between the two. What? Okay, there we go. Let's do that again and just do rounded shaded vertices. This is just another type of shader. Surface shaders are Unity specific, and they specifically make Unity lighting easier. Surface shaders do not work if you are using the new render pipelines. They're not available. It's a totally different thing. Basically, they come with this, and instead of doing vertex shaders, they do a surface shader. Or instead of doing a fragment shader, rather, they do a surface shader. You can still add a vertex shader to this. So anyway, this is what these properties end up looking like. All of this is more Unity focused. This isn't actually describing your shader so much as it is describing to Unity's editor what properties should be exposed and what values those properties should have. So in this case, ranges are going to be a floating point range between some value and some other value, in this case 0 to 1. And then 2D is a texture. Color is some color, so it's going to be red, green, blue, and have an alpha channel. So there's 4 colors there. The last one is the alpha. And so basically we want to just take this, I guess we'll grab glossiness, and just bring it over here. I should point out at this point, I have no idea how this is going to turn out. Again, brainworms, so just kind of want to see what happens. And if it turns out cool, great. Then it might be useful for something. It's probably not, though. This is probably just an experiment that will be thrown away. But we will do grid size. So there's some decisions that we need to make here. We're creating a grid, but we actually need to figure out where that grid is located, and what space it's located in. So there's multiple different unit object spaces, I guess. The first one is like object space. So if we talk about, I don't know, like a cup or something, if you're talking about a cup, that cup is relative to itself, and it has some handle and some other bits. And those, if you create another cup, they're the same thing. But each of those cups is located in a specific spot. Here, we'll use a teapot. Teapot is in space, right? I can move it around, but relative to itself, the teapot is always the same. If it's rotating, it's just rotating in space, but the teapot itself isn't rotating. And so this is sort of object space. Object space describes the teapot. World space is in your game. That's your world, right? So when I move this around and rotate it, that's the world. But then you are seeing this so that you have a camera that is looking at this object. And so I can rotate this in the world, and that actually changes it relative to the camera. But what the camera sees is different than what the world sees, if that makes sense. And because we can have multiple cameras, I could have a separate webcam somewhere over here. Two different cameras seeing a different object in a different way, but it's located in the same spot in world space. Super complicated, but when we're talking about grids, where we want to snap these vertices depends on which object space we're using. Because if we're talking about object space, what will end up happening is all of the grid-locked teapots, I guess, will all look the same. And as we move them through world space, they will stay static, but they will be snapped. If we snap them in world space, what's going to end up happening is as we move that object, the vertices are going to move and manipulate and kind of crawl along that grid, because the grid is based in world space, right? And so as this object shifts through that space, there is a difference in results. And then that change just keeps going up and bubbling up. So depending on what effect you're going for, you need to change this accordingly. We're just seeing what this even does, so we can figure that out later. Anyway, long explanation, but let's do a float here, and we will just say grid size. And so by creating this grid size thing, we actually need to come down here into this pass and declare a float with the same name. So float grid size, this is going to tell Unity, find an object named grid size in our pass and set it. And so that's what that is going to do. And once we've done that, we can access it and use it. So here is what our vertex shader looks like. Unity generates this for you, so you don't need to worry too much. It's basically translating your vertices and your UV coordinates into the correct space. We want to manipulate the vertex, but I'm going to be working in object space. Clip position, which is what this is that camera space position. And so in camera space, like, it's just a 2D image, right? The video you're watching is just a 2D thing. So why is there more than two coordinates? The other coordinates are like depth, so how far into a scene the object is. And that's actually going to determine things like occlusion, for example. So is an object in front or behind of another object? And so you can actually manipulate that with this. Because we're in clip space here, if I come down here and start doing this, the manipulations we're making are relative to that position, that space. What we actually want is to manipulate the vertices. So v.vertex is what we want to be manipulating. This clip position is actually a combination of multiple steps through that object space. So from object space to world space to perspective space, a whole bunch of things. If you want to explore more about that, Unity's documentation has some stuff on that talks about that, and you can actually break this down and sort of grab halfway through this and grab like world space, for example, and that way all your objects will snap to a single grid across the entire scene. I imagine if this actually is something you want, that might look the best, because everything will all line up just because of the magic of shaders. In this case, experiment, so we're going to do the easy thing and just do this, but you can do whatever you want. So the way that I like to do grids. I've done this in like our pixelated shader that we did a while ago now. Basically, we want to get this into whole numbers, and then take those whole numbers and round them to the nearest, I guess, integer value, and then remove whatever we use to get up to that point. So we're creating a grid size, and so we can just multiply or divide by that grid size. I think we're going to divide because I'm probably going to be using fractional things, so we'll get it up a specific size. So if we do grid size like this, v.vertex equals, I don't think you can do this, but we can try. I don't think you can just apply functions to sets like that, but we'll see what happens. Maybe it'll work. And then we're just going to reassign back to the vertex and just say times equals our grid size. So this operation and the second operation should cancel one another out. That's what those are there for. The reason we're doing it is because we want to increase to a specific grid size. In this case, we're dividing by whatever our grid size is. So 0.1, for example. If we say 0.1, if we have vectors between 0 and 1, what that's going to do is divide by 0.1. So instead we have vectors between 0 and 10. And then we're going to round those. So all the bits in between move to the nearest integer value. And then we're going to multiply again by 0.1, and we get back down to that 0 to 1 range. But the only resulting values are going to be 0, 0.1, 0.2, 0.3. You couldn't get 0.25 because we had already rounded things. So that's the purpose of this operation. And then after that, we just plug it into here, and it should come out, and we get a result, whatever that result is. And in this case, everything becomes a cube. That's not what we want. But I think it's because our grid size is 0.5. If we reduce this to 0. Oh, geez, that looks weird. Can I use something that isn't? Why do I have emojis? I don't know what I'm doing. There we go. Okay, this is weird. But this, honestly, that looks kind of neat. But this is sort of what we're gonna end up getting, right? We have this cube thing that is no longer a sphere. It was a sphere, and now it is this. And as we increase the grid size, things start becoming different. This honestly starts looking like voxels when we do this, which is neat. I'm not sure if that is an accurate representation, because you'll see with the capsule, the reason I have all these different shapes here is because things are not necessarily going to always look nice like this. Things are in Unity are kind of composed of triangles. And so what I'm expecting to see is as we shift up in this, we get like these weird artifacts, and I'm not honestly seeing too many of them. But my expectation is, yeah, we'll get things like this, where things clearly aren't doing what we want them to. In this case, we have a whole bunch of what we would expect to be cubes, right? Because they're aligned to a grid, but they're triangles. And so the mesh that we are seeing, the faces of that mesh are composed of the different triangles. And so two of those triangles may align on one plane and another one may be on a different one. So the planes aren't necessarily going to be across the X, Y, or Z. They could be anywhere. They probably would be like right-ish angles. But again, it's kind of a guess. This is sort of just making it up. So you will get these kind of points, I guess. You can't just use this to create weird voxels of some mesh that you want. I don't think that would work for you. But if this is some art style that you want for some reason, Go for it. I guess this is kind of neat. I'm not entirely sure what this would be used for. But I am actually going to go and take this surface shader that I have and add a vertex shader, and we're going to get it in there. This will get us lighting, because I'm pretty sure lighting is going to break with this. Lighting is based off of the normals of things, and we just destroyed all of that by doing this. So there's no way those are correct. And so I imagine the lighting of these objects is all over the place. And there's probably some way to do that. I would imagine if you're doing something like this, vertex based or vertex colors might be useful, because I think you could do some cool things with that. Lighting is, it's gonna be weird. But I will be right back. I'll just do this. I don't, off the top of my head, know how to do that. So we're just gonna go look something up, and then I'll be right back. So see ya. All right. So I have added the vertex shader. It's super simple to add them to surface shaders, but they do behave differently. And I may have done this wrong. I haven't actually tried to see if it compiled yet. We'll just go with it and see what happens. But basically, you do the same thing. You declare a vertex and then give it a name, a vertex shader, and give it a name. The syntax is slightly different. There is a colon between the two, and the function is also different. You'll notice the inputs have changed. So there's now an input and an output thing. So we're declaring this as like an in-out. So this will be the input and the output of this function, and it will then end up in here somewhere. Also, it isn't, I don't think, a vertex shader necessarily. I think that's already been done. This is a vertex modifier. I, off the top of my head, am not entirely sure what the difference is, but I'm pretty sure this is an object space. I could be wrong, so we'll see. But I'm pretty sure this is an object space manipulation. I don't know how to confirm that yet. So yeah, don't know. But we're gonna effectively just copy what we did, because it should just work. I'm also amazed that this round worked. That's something that I've learned. But that's cool. So we are going to just do this and take this. This is from Unity's surface shader examples. That's usually a good place to pick up like basic shader example things. So this is just modifying it by extruding it along the normals. The normals are probably why this isn't going to work for lighting, because they're not really necessarily going to do what we think they're going to do. If you're unfamiliar, a normal is sort of the face direction. So if we're talking about a hand, I guess, the normal is going this way because that is the way the outside face is going. It's used as a way to generate light. By using those, you have the vector of where the thing is facing and where the light is coming from, and you can use that to calculate what the light looks like. Have a different video on that. We're not going to cover that here. But basically, normals are the way a thing is facing. They don't necessarily relate to the triangle. So a triangle is going to form a flat surface. Obviously, with things like circles and spheres, that you don't just have flat lighting. So there's something else going on there. And that interpolation is all done by shader magic. You usually don't need to worry about that, but that's typically how this stuff is done. So let's get rid of that and stop talking about it. There we go. Let's grab our grid size and just pull this in. And we really should just be able to reuse most of this. I am going to change this though to like 0.1, just to avoid that 0.5 was too large and we weren't getting any useful results from it. So hopefully with this we get something useful. Hopefully this works. I haven't actually gone back to Unity, and that's usually when errors pop up. We didn't get any, so I think this worked. I'm just going to replace this. You just do that by dragging the shader onto the material. You can also select it from up here in the shaders thing. I just find it's easiest to just drag it onto the material. It automatically assigns it for you, and everything's good. It should also pull over properties that match between the two. So in this case, we had a matching main texture. So it brought that along We also had a matching grid size, so that was pulled over as well. So we can effectively just switch between the lit and unlit versions of this just by dragging the shaders over, and all of our properties don't change. So this is what lighting looks like. It's not as bad as I thought. Probably easier if we get rid of this. Here we go. Yeah, that's about as bad as I was expecting. So now we have shadows on our objects. The shadows are generated by Unity's, I think this pull forward shadows. I think if we drop that, things will behave a little bit nicer. There we go. So we didn't add shadows, like self-cast shadows. And so I think that fixes things. Clearly they're still not working because the shadows that things are casting are from the original object, not our new thing. The way you do that is with a shadow caster. We're not going to do that here. But this isn't as bad as I thought it would be. The lighting doesn't look great, and I don't think it's worked. You can tell, like, we have faces. Everything should be white, right? If they're facing forward, things should all be white. But like this face here is gray because the normals are actually coming out the side here, not towards the camera. So those are just not correct, and that is causing all this weird lighting so faces that are facing the same light direction actually aren't, and so we're getting this weird stuff. We could probably solve that. I'm not going to, but it's probably something we could do. Generally, though, I think these kind of weird artifacts are just sort of a side effect of whatever horribleness this is. Yeah, so that vertex modifier is object space, I'm assuming, because we're not getting any changes by moving the object. And that should also become apparent when we rotate it. So by rotating this, we would expect, if things were snapped to like world space coordinates, for example, we would expect this to change pretty significantly. Actually, for a sphere that we're rotating, we would expect it not to change at all. That isn't actually how that would work because, again, it's not a perfect sphere. There's still vertices in there that are being rotated around. But for the most part, it would be a no-op. That clearly isn't what's happening, though. We're clearly rotating this. So I guess this is a thing. I don't know what I'm doing. This is all a giant mess. Yeah. Hopefully this is interesting or useful. I don't know if this is useful. I just wanted to do something like this because it seemed like it would be weird, and there is no way anybody else has tried to do this or thought it would be useful to teach people. If you use this, let me know, because I would be really interested, honestly. I'm sure there's some use for this. I can't think of it off the top of my head. I have no idea. I'm actually going to, before I sign off and end this video, I'm going to pull in a few other models. Like, rather than just using primitive shapes, I'm curious what happens if we pull in like real models, like maybe a human or something. What happens then? I don't think anything good, but there's only one way to tell, and this isn't it. So we're gonna do that quick, and then we'll wrap this up at this horrible adventure of whatever this is. So I will be right back. Okay, so I have pulled in this more complicated than it needed to be bomber bug. That is the name of the asset that this is. This is just a random asset that I have that seems like it has the complexity to cause something interesting to happen. So I don't know how this is gonna go. I don't know what's gonna happen. What the heck? Oh, so this clearly has multiple objects. I didn't anticipate this, so we're just going to make mistakes and see what happens. I'm not going to apply this to everything, but This is interesting. So a few things that I can already see that are happening. One, things are disappearing. That's expected, because we are actually like moving things back into themselves. Effectively, why things are disappearing is all of the vertices are being crunched into a single position, and then there's nothing to draw. Um, Part of that is because our grid is way too big for this mesh. It actually doesn't. I could see people drawing similarities like voxelized, like marching cubes style meshes, and maybe they're not wrong, but this is a weird look. Yeah, I don't have anything else. This is I interesting. I guess I don't know what was expecting. I don't know what you were expecting. But this is the results. We could go back and apply the actual texture. There's probably something in here now that has a texture that, yeah, like you can actually texture these and get something. I don't know if that is useful at all. I don't think that that's particularly great. And depending on the values we plug in, we get completely different results. But there's probably something interesting to do with this. If you have ideas, leave them in the comments and I might take a look. But no guarantees. I don't know if there's a reason to come back to this. But yeah, I will leave this here. This has just been a random experiment that I kind of had. Hopefully it covers a few of the things around shaders that you may have had questions about. And if not, hopefully it's just a weird thing that you thought, I don't know, makes you think something different about Unity. There's lots of different options and lots of different ways to do this. Shaders are just math. So anything that you can think of a math function to do, shaders can do it for you. And you can do weird things. Some things you probably shouldn't do. This might be one of those things. But I'll leave that up for you guys to decide. So until next time, I guess I'll see you then. There we go. Screw up the intro or outro. Yeah. Anyway, see you in chat.